introduce yourself.
My name is Coleman Holland. I work at SSAB. My personal safety commitment is to always pay attention to the lockout tagout procedure to prevent accidental machine startup. And this is my capstone Part E project on the SSAB heat treat process cool down water. Start with is SSAB. SSAB is a global steel manufacturing company. We produce specialty steels such as Hardox, Strengths, and Armox. We also produce mild as rolled steel and steel coal. We make all of our steel on site from scratch, and I'm currently in the rolling mill as a mechanical maintenance and electrical maintenance apprentice. This project was done on a water system in the heat treat department. Our problem, pump cavitation. So the problem in this scenario is the cavitation of our main centrifugal pumps. Depending on the severity of this situation, the solution could easily range from replacing the pump's impeller to replacing the pump entirely. Some of the benefits after this project will be done will include a new and more efficient pumps and knowing how to diagnose and repair future issues. Equipment description. This is a process cooling water system in the heat treat department. This sends water all across the department, and then it involves several 500 and 700 horsepower motors that drive centrifugal pumps to move the water to its designated area. This process involves process cooling equipment, furnace cooling, and our temper loop and blowdown water. This is a PNID, so there are 4 700 horsepower low pressure centrifugal pumps, 2 high horsepower, and then 2 temper loop pumps. So these drive it to the process cooling loop and the process low pressure and high pressure loop, and then the rest of it goes through the temper system and through the blowdown water, and then it goes into it all falls in this warm water basin where it is then pumped back into the main tank, and then when the water that's in the main tank is constantly being recirculated through the 2 chiller pumps, so to keep it under 82 degrees. Instrumentation and process concepts. This system involves pipes in many different materials and sizes. It includes pumps, motors, and many different pieces of process equipment. Water is sent from the main tank to the process cooler, and it then flows into the warm water basin, back into the main tank, where it is then circulated through the chillers. This also cools furnace components and leveler hydraulics. Problem analysis. So this pump, somebody walked past this pump one day and realized it was making a very large crackling sound. And they also noticed that the equipment was not getting the proper amount of water. These signs can point to pump cavitation. Root causes can be a clogged supply line, improper piping size, or insufficient water supply due to a clogged filter screen. Troubleshooting process. A diagnostic procedure is done to visually inspect the pump's behavior and look for the area that the water is being supplied to make sure that it's getting enough. You can test the pump by manually running it or watching it automatically run. Taking a flow measurement to see if equipment is getting the proper amount of water. You can use your hand to feel for pump vibration or listen to abnormal sounds. Solution implemented. The pump's body turned out to be okay, and we just replaced the pump's impeller. And the screen was also inspected to make sure that it was not clogged, and it was. We had found some rags inside of it. An engineering system is being talked about to implement a better filtration system. Safety considerations, the equipment needed to be locked out. We locked out switchgear, drives, and gate valves and knife gates to ensure that no water flow could happen while we were working on this, and that nobody could electrically activate the motor or the pump. PPE included our regular FR clothes, Compto, metatarsal guard boots, hard hats, safety glasses. Technical calculations. So with this system specifically, the low pressure section makes about 35,000 gallons a minute. High pressure produces about 8,500, and the temper loop and blowdown water combined it makes about 5,500 gallons per minute. The motors vary in horsepower. The low pressure is about 700 horsepower, and the high pressure is about 400 horsepower, and the temper loop motors are also 400 horsepower. Cost analysis. We used a Broderson to lift up the pump's impeller and lower it in the new one. We keep our equipment there year round, but from one day of the Broderson is about $600. A pump impeller was about $1,000, and then man hours, $75 per hour for 4 hours is $300, and there were about 3 people working on it, so that's about $900 in man hours. Downtime, about $5,000 per hour, 4 hours, which is $20,000. Total cost would be around $21,900 or $22,800. Project results, fix the cavitating pump and inspect the screen. Fixing the pump allows the equipment to receive the proper amount of water and allow us to do our cooling process efficiently and properly. Lessons learned technical. We learned more about how the pump operates and how to replace its internal parts. We learned how to safely lock out and work on the equipment. Communication is very important to communicate whenever you notice new problems so that you can repair them or fix them before the problem becomes too severe. And the importance of planning regular maintenance and proper preventative maintenance schedules needs to be prioritized. Future recommendations: preventative maintenance, keep the screens clean and try to minimize the amount of trash that gets pumped back into the main water tank. Upgrades: we upgraded from the regular factory impeller to a better quality, more high grade material impeller. Optimization: we need to optimize clean water rotation. And training: we need to train people on how to recognize abnormal situations like vibration or pump noise. Professional reflection: skills learned are learning how to replace this pump or replacing parts inside of it, learning how it operates and how it helps our process. And this skill can be applied to many other situations around the mill, as this is a very common type of pump that we use. These are the references. Did you ever